New Orleans branch of the NAACP.
Good morning, judges. My name is Connor Shaw. I'm part of the New Orleans branch unit 6071B of the NAACP. Today, I will be presenting my project from kitchen jars to jet engines, expanding access to STEM through low-cost design by me. So my background for this project is that a lot of underprivileged kids in poorer neighborhoods don't get a lot of chances to explore things like STEM and engineering because it can be very expensive and can be very closed off if they don't have the right opportunities. Especially things like aeronautical engineering and mechanical engineering can be very, very hard to start with because they have very expensive and very complicated topics. So the goal of my project is to find a safe, cheap, and effective way to make pulse jet engines using everyday materials like jars so more students can try safe, hands-on experiments that can make them more interested in things like engineering. So my research question, which jar design creates the most powerful, the safest, the most reliable, and the most cost-effective pulse jet engine? So this project will eventually show how things like engineering can be cheaper and more accessible to kids who don't necessarily have the funds or the abilities to get into fields like this. So the basics of my project is something called a pulse jet engine, and how it works is you spray some type of reactant like gasoline into the combustion chamber of the engine. It ignites, and the exhaust pushes out hot gas from both sides, creating force. A vacuum of low pressure vacuum is inside the combustion chamber, and it intakes fresh oxygen and the old superheated fuel. It compresses all of that, and then that superheated fuel combusts new fuel, and then the whole cycle is a self-contained process. And as long as you provide it with fuel and its combustion chamber is still active, it will not stop until you stop it with something like a rag. So my hypothesis is that a jar since the pasta sauce jar and the salsa jar have thinner walls than the fruit jar, both of them cracked under high temperature faster than the fruit jar because they have thinner walls. Since the fruit jar had thicker walls, it normally lasted a lot longer than both of them.
Were you able to dive deeper into why one only started on its side and one didn't start at all?
Yeah, so the reason why the fruit jar had to start on its side was because the reason why was because it didn't have a flat enough surface at the bottom. So all the liquid was pulled up more than at the salsa jar or the pasta sauce jar, and need to have a thinner amount of fuel at the bottom of each jar. So if you put the fruit jar on its side, it's a lot more stable and it has a lot thinner of a surface area for the fuel and the fire to react with. So it can actually produce a reaction instead of, like the other ones, than the pasta sauce jar and the salsa jar.
Yeah, it was a very good time here. I love being able to come to Chicago and support my community. I loved everybody's presentations. I loved everybody doing their craft, and I can't wait for the award ceremony to see what they decide.